All right, good morning, Calc classes. I am doing a quick video today. I do apologize for being gone, but I am still not feeling well from my migraine the other day, and I just need to kick this thing. So I do apologize, but we are going to continue that process of breaking down this whole idea of U substitution and how it works and what are different, special cases and what happens if this. So today's kind of another day of building some of those examples and situations. All right. So we talked about yesterday that we have these things, we can't simplify these integrals because there's multiplication or there's division or there's stuff plugged in, something like that. And without those derivative rules, that doesn't work. Oftentimes your u is your denominator, your thing plugged inside a radical, something plugged in. And then we also discussed the idea of it could be something whose derivative shows up, which were some of those kind of arctangent examples we ended with yesterday. Okay, so kind of continuing this process, let's look at one where my u is again my denominator. Okay, so let's try this one. Remember, breaking down, we're switching our independent variables. So when I take the derivative of u, it's du. My derivative of 5x squared, I'd power out, power down. But then my chain rule, I could say times dx, derivative of 7 is 0. Now when I go to start kind of comparing pieces, I don't have a 10x up here, so I'm going to move my 10 over. So let's divide 10 over. So I now have 1/10 du equals x dx. Okay, now I'm going to do kind of that same circling with different colors. So here's x dx. Now when I circle up here, I notice I actually have an extra 3, which I can't include that. You can't split that 10 up by like subtracting because it's multiplication. So I can't break my 10 really up even to get that 3 gone. I've got, let's go with this color instead. Here's my 5x squared plus 7, and there's that part. So almost everything gets replaced, but I still have this times 3. Well, what happens is this is just a constant multiplier, and I can pull that 3 out of my integral. And you might be wondering why I wrote it so small right there. That's because I kind of think ahead, and I'm like, I'm going to have to put a 10th in here. And if you remember yesterday, we always put that in front, and then the du at the end, just to get the constant out of that integral, so I could just take care of it at the end. And so that's exactly what I just did, except for the 3 joined it out front. Now you cannot do that with this 5 because this 5 is not just multiplying the x squared. It's after that you're adding 7 and that all is lumped together. So you cannot pull this, this 5 out or this 7 or anything. It's only the 3 because it's only multiplying x and it's in your, nothing else in your numerator for it to combine with. Okay, now when I make my substitution, so I put the 1/10 and then x dx in, I put, okay, doing my other substitution, the u is going to take the whole denominator. And then I do want to put a placeholder of 1 on the top so that it doesn't look like a fraction bar with nothing in the top. All right, so my antiderivative then, the 3/10 stays. My antiderivative of 1 over u, like we talked about yesterday, is that absolute value natural log. And then don't forget those plus c's. If you forgot those on your homework yesterday, go add plus c's to everything. And then last step was just get back in terms of x. So natural log 5x squared plus 7, and then a plus c. And then that thing is your antiderivative. All right, let's try the next one. So I've got cotangent. Now, cotangent maybe is something that has a rule out there. I don't know it if it does. And so you might be wondering how this is u substitution because it is just cotangent of x. There's nothing plugged in, there's nothing multiplying, there's nothing dividing. But I don't know my derivative of cotangent. And so one strategy, and this did show up in PreCalc C, which I know we were in distance, so we're going to kind of review here. Tangent can also be written as sine over cosine. Okay, which means cotangent can be written as the reciprocal. So cotangent is the reciprocal of tangent. Oops, I just wrote tangent. I went to right side. So it's cosine over sine. Now you're in a fraction, and now you need a u substitution. So we got to kind of think, all right, which one should I u sub? Because they're derivatives of each other. But which one's like plugged in, and in this case the plugged in is your denominator. So it's going to be the sine of x. Okay, derivative, so du equals cosine x dx. Okay, doing kind of that process again. It's up to you. You don't have to write this. I just do it for you. Underline, underline. So everything gets directly replaced right there. There's nothing left, no constants even. So I'm going to have 1 over u du. Antiderivative is your natural log. Now, I could just write u there, but if you're kind of seeing the pattern, you always switch back to x anyway. So if you want to make that step into 1, so instead of writing the absolute value of u and then the absolute value sine of x, you can just substitute right away. That's fine as well, if you're getting that pattern down. All right, let's keep progressing through our examples. So I've got a linear over a quadratic. Now, u substitution. So if you're like, let's make the bottom u, I agree that x squared and plus 1, its derivative is a linear, and that would take this spot, but this minus 2, you can't just skip over it. So I sometimes will have kids that they're like, oh, I got a linear, and they do this. And I'm like, well, the x minus 2 is one term. You cannot split that up when there's subtraction or addition. It's kind of like saying, oh, let's just divide those and those. Well, you can't do that because there's adding and subtracting. Okay. So we need a different approach on how to do things that my u substitution doesn't actually take the whole numerator or whole denominator. So the approach we are going to take is kind of combining our ideas of simplifying from the day you quizzed and then our u substitution, is that I can simplify this and break it into 2 integrals because I can split my numerator. You cannot split your denominator, but I can change this. I'm going to put a minus symbol there then, as 2 over x squared plus 1 dx. So I can divide my numerator in 2 parts. Okay, and then I'm going to draw a little dotted line. So what this dotted line represents is I'm going to do, now that these integrals are separated, each one is just its own problem. So like this is one problem, it's going to be done totally isolated. This side's going to be done totally isolated, and then at the end I'm going to subtract their quantities together. Okay, and so what that's going to look like, this one needs my u substitution because I need that x squared plus 1. So then du is 2x dx. Okay, I don't want the 2, so I'm going to divide my 2 over. So I have a half du equals x dx. Okay, so circling parts here, that part matches. I just made the denominator u, so now my integral is 1/2 1 over u du. Okay, so putting it all together, I'm just going to write it down here for myself. So I've got 1/2 natural log of u, and then again u is x squared plus 1. Now I'm not going to put a plus c because this is all really one problem. I know I said you can use them, kind of do it as 2 separate problems, but your answer is 1. So at the end of the whole thing, I will have a plus c, but you're not going to have 2 plus c's along the way. Plus, if you have a subtraction between them, you cancel them. So this does not get its own plus c. Okay, now over here, I can't do a u substitution because I would get a linear, and there's just a constant up there. So take a second and think, what is this thing's antiderivative? It does not use a u substitution. I'm going to give you a hint. I'm going to give you another hint. Hopefully that one maybe triggered it for you. This thing is just arctan. And I didn't have, so it's still in terms of x because you never, like I said, you didn't do a u substitution. The 2 is just a constant multiplier. There's nothing with it, so I can pull it out. The denominator, yes, it's technically backwards that you were supposed to do 1 plus x squared, but addition doesn't matter, the order. So it really is just that arctangent then. And so this whole thing is your answer. Okay. So this is one new, like this is definitely a new strategy that we did not talk about yesterday. Okay, let's try one more. We'll call this example 6A, because I made it up here. Example, it's an E. There we go. All right, let's start analyzing this one. And so we talked about stuff plugged in. Well, this square root, that I've got this chunk inside, there's no way to do an antiderivative of stuff square rooted. And so that has to be our u. Okay, so 9 minus x squared. Okay, take the derivative of that. Du is negative 2x dx. I definitely don't want my negative 2. Let's divide that over. So negative 1/2 du equals x dx. Now yesterday when we did some of these and we got to this point and we compared x's, we noticed we had way too many x's. In this case, I don't have enough. So like the extra pieces are this x cubed and this dx, but I only have one x, not x cubed, that were found in this process. So strategy, what do? We're missing some x squareds. We're going to do kind of a partial substitution, and we're going to end up kind of substituting twice along the way here. So to analyze this x cubed, I'm going to rewrite it as x squared times x. Sorry, that's a squared. Okay, now the reason for that is if I do some circling here, I do have x dx and x dx. Okay, so if I do kind of, like I said, a partial substitute here, I've got my negative 1/2. I have x squared left because that part didn't get replaced. And now I have the square root of u du. Take a minute to kind of look that over, see if that made sense. Okay. So just again, I had to use this stuff under the radical because there's, other than arcsine and arctangent, those have some 1 minus x squared and that can be under the square root, but then it needs to be in the denominator. So there's nothing that's going to go in here. So that had to be my u, but when I took my derivative, I was short because I needed x cubed and I only had x. So instead of just crossing this out and saying that's the wrong one, I took my x cubed and I took one of the x's away, separated it off basically, so I had x squared left. Then that x dx became my negative 1/2 du. Okay. Now you cannot take an antiderivative right now because you have u as your independent variable, and now you still have an x squared in there. So this is where we're going to substitute again. Now I want to know, like I need to replace x squared with something in terms of u. So looking at my screen, where do I have something with x squared in it that also has a u in it? It's right here. Okay, let's solve this for x squared. So if I add x squared and I subtract u over, x squared is 9 minus u. And so this can now substitute again. I didn't have to make a new u, like it's not another substitution, it's just using your same u and doing another round of substituting. So I've got negative 1/2, now I have 9 minus u. I'm going to write this u to the 1/2 power because I know with antiderivatives I'm going to need the half instead. I still can't take an antiderivative though because I have stuff multiplying. So I do need to distribute here. So negative 1/2, 9u to the 1/2 minus, and then with this as a power of 1, I would add those powers. So it'd be a 3/2 power du. All right, now it's a straight antiderivative power rule. So I have negative 1/2. I am going to put some brackets here. That's maybe a little big, but all of this stuff needs to get multiplied by the negative 1/2 because it's all in the integral. So I've got a 9 power up to 3/2 power over 3/2 minus this one would power up to 5/2 and then over 5/2. And then, like I said, I made it a little big. So plus c on the end there. All right, my last step then, I'm going to do a little bit of simplifying along with, I need to put x back in. So I'm going to slide up a little bit here, give myself room. So I'm going to distribute my -1/2. I'm going to keep some of the structure here, just because I know when I put u in, it's going to get a little complicated. So this is 9. When I divide by 3/2, that's the same as multiplying by 2/3. And then I would have 9 minus x squared to the 3/2 power. Okay, same thing on the next one. Divide by 5/2 is the same then as multiplying by 2/5, because it reciprocates up. And then here's your 9 minus x squared to the 5/2 power. And then your plus c. Okay, and we're fine if you leave it like that. Yes, like you could do 9/2 or 9/3. Here's 3. If you distribute in this half, you're going to have some stuff cancel. But we would rather have you do correct antiderivatives versus worrying about, simplifying and all those kind of steps. All right, we got 2 left. We're getting close here. All right, I'm going to have you give me a guess for u, and then see if you can make that substitution. So pause the video, try in a moment, pause the video after. I want you to try what your u would be, and then make that substitution, and I will give you the hint. You should substitute twice. So pause the video and give it a try. All right, my only option for u, because of this cubed, is that 4x plus 8. There's no other way you're going to, unless you multiply it all out, which sounds terrible. You can't distribute x in because your cubic would have to be done first. So there's really no simplifying. And so I make my u and I find my derivative. So du equals 4 dx. Okay, and I want my 4 there, so I'm going to make it a 4th. Du equals dx. Now, in terms of switching and substituting, you got dx taking dx, you got 4x plus 8, 4x plus 8, but you still have a lone x left. So I'm going to put the 4th, the du, I'm going to do this be u cubed. So I still have this x. And here's where we substitute again. So I need something that relates u and x, so I can replace x. So I solve for x. So I would have u minus 8/4 equals x. I substitute that in, so a 4th u minus 8/4 times u cubed du. And now there's some different paths you can take. One thing, we have to distribute the cubic in because I still have multiplication, so I can't simplify here. So this is going to have to multiply in. The one other thing that will make your life a lot easier is this divide by 4 can be pulled out because it's a constant multiplier, divider in this case. And so when I pull it out, it's 1/16. And then the integral would be u to the 4th minus 8u cubed du. And if you didn't do that, and if you kept it along the way, it would still end up the same. So it's not a big deal. You just have to make sure you keep it around. Okay, so taking my antiderivative now, I'm going to power up to the 5th over the 5th, power up to the 4th over the 4th, plus c at the end. Okay, putting that u back in, or x back in for u, I should say. I would have that 4x plus 8 to the 5th over 5. 8 times 4x plus 8 to the 4th all over 4. And then that stuff plus c. And again, that's totally fine. If you want to distribute the 16th in, you can make this 2. 8/4 is 2. But again, those are kind of minor details in the grand scheme of this whole thing. All right, we're on our last example. And the next kind of days here are going to be just a lot of practice this stuff, because I know it gets to be a lot and all mixed together. But just like derivatives, once you do a bunch of ugly ones and practice, it does get better here. All right, so I could split. Okay, I do have, the 3x over this quadratic, and I could do the 2 over this. I actually don't have to do that in this case, and there's going to be approaches that you could take multiple approaches you could take, I will say. But in this case, let's try making your u be x plus 1. Okay, so we take our derivative, so du, switch colors on me, dx. And so kind of like the last one, we got to kind of analyze what is going to get replaced and what is still stuck there. Okay, so this x plus 1 is going to become a u. The dx is going to become du. And I still have this numerator part here. Okay, so let's make the substitution and see what happens. So that's still there. Now I'm over u squared, and I have du. Okay, so you're like, oh great, that didn't, still got an x. But you still have an x, and you now know what x and u, how they equal each other. So u minus 1 is the thing that equals x. So what I'd like to challenge you to do is, when I'm done here, you're going to pause the video and try the end of this yourself. So make the u substitution and take that antiderivative and see if you can then hit play and match, see if you match what I have. So go ahead, hit pause, and try finishing this. All right, so making that first substitution, we have 3. Now a u minus 1 goes in for the x over u squared du. This format, we can't take an antiderivative, excuse me, yet. I need to do some simplifying. I've got this whole numerator thing. So this would be 3u. If I distribute and add 2, it'd be a minus 1 over u squared du. I still cannot take an antiderivative, but what I can do now is I can break up and divide my top and my numerators parts separately. So I would have 3 over u and then minus u to the negative second du. Okay, so now my antiderivative is 3 ln absolute value of u minus u, so power up to negative 1, power over negative 1 plus c. And then that last step, make sure you put the x back in. So 3 natural log x plus 1 minus x plus 1 to the negative first over negative 1 and plus c. And again, we're totally fine leaving this without simplifying. Yes, you could make that plus, and yes, you could put that in the denominator. And if it's multiple choice, yes, you've got to do those things. But if it's not multiple choice, then you're good. Just leave it like that. Okay. I do just want to show you this problem again because some of you may have divided, because you do technically have one term in your denominator, and you can separate this and go about this in a little different approach, but you get the same answer. So I'm just going to kind of show you that just to be thorough here. So I can divide my top numerator parts separately. So I'm showing that here. So plus, and then it'd be 2 over x plus 1 squared dx. So there's breaking that 3x plus 2 up. And then kind of like that one we talked about where we break up, that you're really just doing 2 integrals, and then at the end you add their properties back together and do 1 plus c at the end. And so this one, I still need a u substitution. So it's that x plus 1 because I've got stuff inside a squared. So du equals dx. Similar substitution as the last one. That the 3x is still there, and now it's over u squared du. Okay, and so I could pop the 3 out. I do need to replace what x is in terms of u, so it's u minus 1 over u squared du. Okay, and then obviously keep going. So 3 1 over u minus u to the negative second du. I keep going down. This would be 3 ln absolute value of u minus 3 u to the negative first over negative 1 would be that part. My second part over here, I could pop the 2 out. I still would have to do a u substitution on this side as well. So this u substitution would also be there again because you have that squared. So I'd have 2, 1 over, well, I'm going to write it as u to the negative second just to make it easier. u to the negative second du. So this thing would be 2 u to the negative first over negative 1. And then kind of combining here. So my final then would be 3 ln, putting x back in, x plus 1, minus. Now if you notice these two, we were supposed to have minus 1 of them. And so you do because you have negative 3 plus 2 more. And so there's where this x plus 1 to the negative first over negative 1 comes from. So this is what was on the last one. So that part got broken into 2 pieces because of the splitting, the separating, I should say. And then, you can put them back together. You could leave them as 2 separate ones, but that's how these 2 things are really the same thing at the end there. All right, this is a lot of information, and it's trying these. So try you, maybe it works, maybe it doesn't. So try a different one. If it doesn't work, leave your work and then check with me next time we're together, and I'll look at it and be like, oh, here's, let's go from here. Let's try this. Talking with peers, we would love for you guys to make, a little calc study group and get together and help each other and practice. And what are you guys doing? And it can be over Google Meet, it can be in person, whatever you guys choose. So here's today's homework assignment. A couple more problems in that same page 340. I put 341, I think it starts on, but same section of 5.4. So good luck, and we'll be checking back in on all of these and working through these.